The range of activities you could do in class is limited really only by your imagination. To help give you a bit of a kickstart on that, let's brainstorm some possibilities. So to start off with, maybe you've got a demonstration. The demonstration doesn't really translate to video because maybe its whole effect is that something explodes at the front of the class and that gets everyone interested. Now, if you're going to have a demonstration, it's a really good idea to have people try and predict what's going to happen and then process afterwards. So a predict correct routine is an excellent way to get a nice active component into a demonstration. If you want to make sure that everybody participates in that rather than just a few people, then try and get them to predict and correct in small groups. Another thing you might have some basic skills that you want them to have, some basic drill, in which case you can just give them exercises to do and you can go around and watch that. If you think students need more work on conceptual issues rather than basic drill, then maybe you should give them more conceptual questions that can often work very well in small group work. Now, typically a small group is something like 3. In 3 people, it's very easy to tell whether someone is just coasting on the others, and coasting is an issue you have to watch out for when you're walking around the room. But some of the advantages are you tend to get proximate learning, so people that are very near each other in knowledge and skill actually teach each other very well. You can actually combine the small group work and the prediction correction model for getting students to refine their conceptual models. And you can do that for the whole class in a sequence of questions, provided you have appropriate technology. So you could use things like clickers or tablets or smartphones and appropriate software. And students can see what other people are voting in terms of responses to a particular question, and then they can get back together in their small groups and discuss that problem and try and come up with a refined prediction. And sometimes we give students basic drill and we expect them to be able to scale up their efforts there into much larger, more realistic problems. And often they actually need help and scaffolding to do so. And an in-class activity where you don't have to cover extra material during the actual class time gives you an excellent opportunity to try some larger, more developed exercises. So what we're doing there is we're trying to bridge the gap between basic knowledge and the ability to apply things. And of course, the extreme version of that is where you take a genuine, authentic application of that knowledge. And so you really want to focus towards an actual output that you want the students to be able to achieve, and you give them some practice at doing that. So in a physics kind of context, which is where I come from, the basic drill might be learning how to use the laws of mechanics. In the larger, more complex exercise, they take that new content and they draw it together to understand a much more complicated system, and then they examine the actual behavior of that system, and so they learn to understand various kinds of behavior as well. Then the authentic application might be design something, now model it, now tell me things about it. In other words, answer the kind of question that they might get when trying to really use this knowledge in a work kind of situation. And the extensions to other contexts is fairly obvious. You have your basic drill, your larger, more complex exercises, and then you have a real authentic application, which is a very valuable way of getting your education to be applicable and useful in the real world. To help get to that point, you might want to focus not on content and learning more content, going through sort of drill and then larger exercises and so forth. You might want to focus on skills. And of course, you can design exercises to really work on particular skills. So you could prep for particular projects, or you could work on a communication skill where students, for example, work on something and then present to each other or present to the class. And really, imagination is your only limit. You could have a role play, you could design a game, you could have students analyze news reports. You could have them referee an application. You could try a 2-stage exam, which starts off exactly like a mid-semester exam where you give students an exam and they work through it and they hand that in, but then you put them together in groups of 3 and then they work through the same exam again and then they hand a group exam paper in and you give them some fraction of their solo mark and some fraction of their group mark. And that turns out to have a lot of good learning effects as well as give you some good summative feedback. And one of the nice things about this teaching framework is you don't necessarily have to give all students exactly the same task because they've already covered the basic content, and so you're free to adjust the activities that different students do on a spontaneous basis. So you can be in the workshop with ideas, with a plan, and you can give a particular student, if they're struggling on some particular area, some other task to do, and they're not going to be left behind. In fact, you're going to be using their time more efficiently. And the only things that can really constrain that are how you're doing your assessment for your course. And so your assessment becomes a really important question on how to design these things, and that's what we'll address next.